In this video, we're going to talk about how we can write equations for a transformed function for both a square root or a cube root function. So this is the same table that we had in the square root and cube root graphing video. And here you can see that, horizontal and vertical translations both consist of addition and subtraction. The vertical ones work just as you would expect. Up means adding, down means subtracting. The thing is that these are added on the outside of the root, so you can see that right there. Then the horizontal ones are added or subtracted inside of the root, so regardless of whether you have a square or a cube root, they're inside, and remember they work opposite of what you expect. So to the right would be a subtraction, to the left would be an addition. Reflections, remember, are being multiplied by -1 somewhere to flip it over an axis. For one that is over the x-axis, remember x-axis is this way, so it's a vertical. That's where we're going to multiply it on the outside. So this one right here is for the x-axis because it's on the outside, and we multiply the outside of the function. So we surround the whole thing in parentheses, multiply it by a -1. For a y-axis reflection, that's a horizontal reflection, that is where we multiply the x on the inside by a -1. So remember, that's how our reflections work. Then finally, we have vertical stretches and vertical shrinks. A vertical stretch or shrink is something that happens on the outside of the function. That's our a value, works just as expected. A shrink, you multiply by the number. A stretch, you multiply by the number. Horizontal stretches and shrinks, remember, you have to do the reciprocal. So we take whatever the factor is. So say the factor was, a shrink by 1/2. When we take a shrink by 1/2, we take the reciprocal, which is 2/1, and we multiply the x on the inside by a 2/1. If we have a stretch by 3, again, we multiply to the reciprocal, which is 1/3, multiply the x on the inside by 1/3. So remember, horizontals are all inside, so this is inside, this one is inside, this is inside, outside, outside, and outside. So instead of doing multiple examples for this video, we're just going to perform all 6 transformations on this singular function here. So you can see we have f of x equals 3 times the cube root of x plus 2, all subtracting 4. And so we have a cube root. This works the same way for a square root, so it's the same process. But we're going to look at all 6 on this same example. So if we look at the first thing, it says we're going to reflect over the y-axis. Now remember, the y-axis, yes, is a vertical line, but the reflection itself is horizontal. Because it's horizontal, it means we're going to multiply that inside x value by a -1. Now what we have to be careful about here is we only do this to x on the inside. So I know there's a 2 there, but we're only going to do this to x on the inside, because if you look carefully in the function notation, it says we're only doing it to x. So here we're going to take f of x, which is, our function that we have, and we're going to multiply this x value here by a -1. So if we do that, we end up with g of x, that's the name of our new function here, is equal to, we still have the 3 on the outside, we still have the cubed root, but now it's just -1x plus 2 and then -4 on the outside. Then from here, the next thing we're going to do is we're going to vertically stretch it by a factor of 3. So this means we're going to multiply by 3 on the outside. So what this means is we're going to multiply this 3 by 3 and this 4 by 3. So our new function, because we're multiplying by 3 on the outside, becomes 9 cube root -1x plus 2 on the inside, and then -12. All right, next thing we're going to do, now that we've checked off the first 2 transformations, is we are going to look at how we can do a horizontal translation. Now remember, horizontal translation is happening on the inside, and this is where we're going to translate 4 units to the right, which is in the positive direction, and horizontal works opposite. So we're going to do a -4. Now what's tricky here is you have to do this to x. So what I like to do is put little parentheses around x, and what we're going to do is we're going to subtract 4 inside of those little parentheses. So this one is a little bit tricky when we already have, a coefficient in front of x there. So we have our 9 value still out in front, we have our 3, we have -1, and then inside of those parentheses with x, we're going to do x minus 4, and then plus 2. And then that minus 12 on the outside. So notice where x is, I added a subtraction of 4. Now, I don't like to leave it this way because we can use the distributive property to simplify this down. So I like to distribute out that -1. So I get 9 cube root of -1x plus 4 plus 2. And then you can see here that we end up with cube root of -1x plus 6 minus 12. So note that tricky part right there, how we have to do x minus 4 in parentheses and apply that coefficient in front of x to the -4 as well. So just being careful with that. That is the trickiest part of this, is paying attention to those horizontal translations and remembering that we have to put x inside of parentheses and distribute something if there is a coefficient in front of that x. Okay, next thing we're going to do is we're going to reflect over the x-axis. Now remember, the x-axis, yes, is a horizontal line, but results in a vertical reflection. And as a result, that's going to happen on the outside. So we're going to multiply the outside by -1. So I'm going to take my function, multiply this entire outside piece by -1. That means that the 9 gets multiplied by -1 as well as this 12 with the negative in front of it. So our new function here is now, we have -9 cube root of the -1x plus 6 is all safely inside of those parentheses, and then a plus 12 on the outside. So we've taken care of that one. Then we have to vertically translate this down 3 units. To vertically translate it down 3 units, remember we're going to subtract 3 from the outside because this is a vertical translation. So we're going to subtract 3 here from the outside in order to give us -9 cube root with -1x plus 6 inside of those parentheses and a plus 9 on the outside. So we've taken care of that one. And finally, we're going to do a horizontal stretch by a factor of 1/2. Now, this one, remember, horizontal means it happens on the inside next to x, and it's being stretched by a factor of 1/2. Now, this should really say shrunk. That's confusing because it's 1/2, so it's being shrunk by a factor of 1/2. And then remember, horizontal ones work a little bit strangely. Just like horizontal translations are the opposite of what we expect, horizontal stretches and shrinks to find our factor that goes on the inside next to x. We need to take the reciprocal of the number they're giving us. So here, factor of 1/2 is how we're shrinking it. So we flip it to its reciprocal, and that becomes our b value. So what we're going to do is next to x here, we're going to multiply this by 2. So as a result, our final function becomes -9 cubed root of the 2 times the -1 here becomes -2x plus 6 on the inside, and then I have a plus 9 here on the outside. So we can check that one off. So notice we can do each of these transformations to this function. You just have to remember that vertical, all those vertical changes are going to happen on the outside, whether you're multiplying by a value or you are, subtracting a value or something like that. And all of your horizontal changes are going to happen inside directly to x. So sometimes we're going to have to add some parentheses around x to help us make sure that we don't make a sign error or something like that.